Thank you for joining this lesson. We're going to discuss linear motion and circular motion. In number 14, part A, the figure below shows the motion of a ticker tape through a ticker timer whose frequency is 100 Hertz. We have the motion already displayed on the tape. Determine, part 1, the velocity at AB and also the velocity at PQ. Remember to subscribe to this channel and to also share the link with friends. So the first thing to determine, even before we go to the velocities, is the periodic time for this ticker timer. Periodic time is usually given by the reciprocal of frequency. Therefore, when we take 1 out of 100, this will give us 0.01 seconds. Therefore, 0.01 second is the time taken by the ticker timer to make a dot and the next. The intervals are made in 0.01. Now we want to get velocity at A, at AB. Therefore, velocity at AB, velocity is usually given by the displacement divided by the time taken. Therefore, a displacement of 12 centimeters now becomes 0.12 meters divided by, if to make or for an interval we have 0.01, then for two intervals we shall have 2 times 0.01. So that now we are dividing 0.12 out of 0.02, and this is going to give us exactly 6 meters per second. Again, we'll be talking about the velocity at PQ. So we go for velocity at PQ. This will be given again by the displacement at that point, which is 32 centimeters, translating to 0.32 meters, divided by, again there are two intervals. So for each interval, we have a period of 0.01. Therefore, in this case, we will be dividing 0.32 by 0.02. This is going to be exactly 16 meters per second. So we have the two velocities for the two regions. In the other part, now we are talking about, in Roman 2, the acceleration of the tape. There is something we are supposed to master very keenly, and that is the direction of the tape. If that is the direction of the tape towards the right, it means region PQ is coming fast. Dots are made in PQ before they are made at AB, and therefore, in this case, initial velocity, the direction of the tape should be very key. To get acceleration, we need velocity initially minus the final velocity. Okay, final minus initial divided by time taken. Now, when we go to the substitution now, the final velocity is the velocity between A and B, and that is 6, minus the initial velocity. Because of the direction, initial velocity is the velocity at PQ. That is going to be 16. Then now we divide by time taken for velocity to change from 16 to 6. So we're going now to count the number of intervals, and this is how we go about it. We start by the regions where we have final and initial. Like in region AB, we have only 2 intervals, 1, 2. So we take a half of that. That is going to be 1. And again, between P and Q, we count the number of intervals. They are only 2, 1, 2. Intervals or spaces, they are 2. We take half of those intervals. But now between P and B, we are going to take the number of intervals there, the complete number of intervals. So we have 1, 2, 3, 4. So the 4 spaces between B and P is going to be added to half the spaces in this region and half the spaces in the other region. Therefore, we're going to have 4 plus 1 and 2. We get 6. 6 intervals multiplied by 0.01. So this is going to be negative 10 out of 0.06. So when we divide this, negative 10 out of 0.06, this is going to give me negative 166. Negative 166.672 decimal places meters per second squared. So the acceleration will remain negative because in any case we've not been told to determine deceleration. So it means the tape is decelerating. That is why initially within 0.02 seconds it could cover 32 centimeters, but as the motion continues, we can see within the same interval of time it's only covering 12 centimeters. So it is decelerating. We can go to the second part. State 2 factors that affect centripetal force of a body moving in a circular path. The centripetal force of a body in a circular path is affected by 3 factors. That is mass of the body. Then we have radius of the path. Radius of the path. And also we have the linear velocity at which the body is moving at. The linear velocity v of the body, radius small letter r of the path. In number C, or part C, a stone of mass 1.2 is tied to a rope and whirled in a vertical circle of radius 3.2 meters with a speed of 6.32 meters per second. Calculate part 1, the centripetal acceleration of the stone. Centripetal acceleration is usually given by v squared divided by r. Therefore, 6.32 times 6.32. Then we divide this by the radius of the path, which is 3.2. Therefore, we can compute this 6.32 squared, then divided by 3.2. This is going to be 12.48. 12.48 meters per second squared. Then in part 2 of part C, we are told to determine or calculate the tension in the rope when the stone is at the highest point. So at the highest point, the rope experiences what we call minimum tension. At the highest point, the rope experiences minimum tension, which is given by the difference between the centripetal force and the weight of the stone being whirled. Therefore, centripetal force is given by mass v squared over r, then minus weight of the object, which is mg. Therefore, to substitute this, we need a mass of 1.2 times, remember v squared over r is the centripetal acceleration, but we can still substitute once again 6.32. Now this one is going to be squared, divided by radius of the path, which is 3.2. Then we subtract 1.2 times g, which is 10. Therefore, we're going to have the centripetal force becoming 14.98. 14.98 newtons. minus 12 newtons plus 12. So we're going to get, when we subtract 12, we're going to get 2.98. So this is going to be 2.98 2.98 newtons. 2.98 newtons. So thank you so much for following. Subscribe and share.